Hello. Let us continue from yesterday's work. Yesterday on Thursday, that is 12th of August, we had already started the vibrations, and in that video, we had discussed two types of vibration, that is the natural vibrations and the damped vibrations. And we found that in both there was the difference of the presence of this external resistive force. All right. Now today we will continue. Let us write the date. Today is 13th of August 2020, and we are going to do third type of, that is the forced vibrations. As the term is given there, force, it has been forced by something. Okay, so now what happens is, in the force vibrations, the vibrations of a body, the body is vibrating, which takes place under the influence of some external periodic force. When it acts under the influence of some external periodic force, then that type of vibration is called force vibration. So here the vibrations of a body takes place under the influence of external periodic force. This external periodic force which we apply to the body is also called the driving force. Okay, now in the previous type of vibration, that is the damped vibration, the second one, we saw there were two forces acting on it, the restoring force and the resistive force, the frictional force. But now here in the force vibration, one more force is added, so the body executing force vibrations, the body executing forced vibrations, in that the three forces will be acting. Okay, the three forces act here. Number one, we know that as in the case of the damped vibration, there will be a restoring force. The restoring force. The number two is the resistive force, which can be also termed as the frictional force. This is due to the surrounding. Okay, and the third, which is added in this case, is called the external periodic force, which is also known as the driving force. Okay, now here what happens is, in the force vibration, the body will continue to vibrate under the influence of this external periodic force. That means the body will not vibrate with its natural frequency, but it will vibrate with the frequency of the periodic force. That means, let me just explain it by taking one simple example. Okay, just let us take one simple example. If you look at this example here, when you suppose this is the string of the guitar, I'm just taking 3-string guitar. Okay, I'm just trying to explain here. You have a hollow box here, and you plug the guitar. Suppose you plug the guitar and leave it, then that will produce the damped vibrations, because that body is vibrating under its natural frequency, and the frequency with time will decrease and the plucking will also stop. But when you pluck and when you continue to pluck, that means you are applying external periodic force. So it will go on producing, it will go on vibrating as long as that external periodic force is there. So that is the third force which is added in the force vibrations. Okay, so now what happens is, in the force vibrations, the body do not vibrate due to its natural frequency. But the body vibrates, or the vibration takes place due to the frequency of the external periodic force which you have applied. And this external periodic force, the amplitude, whatever you get, the amplitude of the external periodic force, it does not change with time, it remains constant if it is a periodic. That means as long as the force is being applied, the amplitude remains same and the body goes on vibrating. Okay, so this is one example. You also have many other examples in the textbook. Please refer to that. So in the force vibration, only one force is added, one extra term is added, that is the external periodic force. Due to that external periodic force, the body goes on vibrating, and it vibrates under the influence of the frequency of this external force. Alright, now there is a special case of the force vibration which we call it as resonance. Now resonance, all of you have heard the resonance, when the sound lingers on for a long time, resonance, okay, it keeps on reso, N-A-N-C-E. Resonance is nothing but it is a special case of force vibrations. Special case of force vibrations. Okay, let me take one simple illustrations to example to explain this resonance. Suppose you take and you pluck your, okay, and you leave it. Now what happens is this body will have a natural frequency. Let us say given by F. Now what happens is when you only pluck once, that means you have given the restoring force, and this body will vibrate with the natural frequency. And what happens to the natural frequency? It goes on decreasing with time, and after a certain period of time it stops. But when you apply external periodic force, when this external periodic force is applied, and this external periodic force has its own frequency, let us say that frequency is given by, let us say this is n, the natural frequency, and the frequency which is produced by this external periodic force which you have applied to the string. Now this body or this string will do not vibrate due to its natural frequency, but it will vibrate due to the frequency of this force. Okay, now there are two frequencies here. So this frequency is the natural frequency of the body, this frequency is due to the applied force here. Now when these two frequencies become equal, then the body will start to vibrate with increased amplitude. The amplitude increases and a loud sound is heard, and that is resonance. So in case of a resonance, what happens is the natural frequency of the body, of the vibrating body, when that becomes equal, when that natural frequency becomes equal to the frequency of the external periodic force, then the body will start vibrating with increased amplitude, and when the amplitude increases, a loud sound is heard. So that is the resonance. So now one question is asked there. State one condition for a resonance. State one condition for a resonance. So it is quite simple. For a resonance to occur or take place, what should be kept in mind? The natural frequency of the vibrating body should be equal to the frequency of the external applied force. Alright, so here we come to the end of these vibrations. We have learned three types of vibrations. Now you have to do this exercise from the textbook. Please complete the exercise in your textbook from page number 156. Okay, and in the next class I'm going to deal with another topic on sound, and that will be the end of this chapter. Keep studying. Stay safe. Thank you very much.